Hi guys, when I look today at the next part in the correlation bit, now I've just got this little schematic that's in your textbook up. The idea of using your data is to try and use it to predict things, what's actually happening between variables. So obviously if we're looking at this example here, we've got some data, alright, so what we can do is we can either extend that data, alright, so into the future, or we can extend that data backwards as well. So this is called interpolation. Right? So when we're using our data where we're actually plotting a line of best fit based on the data. Now, because that is real data and that's telling us what exactly things are doing, we can be very confident that that line of best fit is a good representation of the real data. All right, so we should be really quite happy with that. We need to be careful though when we start extending that data long term. All right, so in terms of how reliable is that data? Is that pattern going to happen long term? So we think of an example. Might be we look at the temperature rise, or we look at something to do with global warming. Right? The people who do that modelling, they base it on data they've been collecting over the last 50, 100 years. And then they're trying to predict what's going to happen in the next 50, 100 years. Right? So when they do a model, they keep looking at the data, they keep tracking it. So every year they look at their model and see how their model's going in terms of predicting what might happen. So it may be that global warming's happening faster than the models are predicting, or maybe we're taking some changes to what we're doing, and that's actually reducing, the effects of the global warming. All right, so you get the idea about that modelling process is really important. All right, so but we do have to be careful when we extrapolate our data either way, whether that's actually going to give us what's going to happen. It's a prediction. All right, that's what you need to keep in mind. Now, the other part of looking at this whole topic, right, is this line, this regression line. Okay, so we talk about the line of regression. And I'll just go up to looking at the example. There's a formula for the least square regression line. So what that relates to, it relates to the line of best fit. And the way they do the line of best fit is simply by plotting the points and looking at distance from each of these points to the actual line. Alright, so if you can imagine, what we're trying to do is we're trying to reduce that distance for all these points. So to minimize that, what you do is you square those, alright, and then you look at the value S that you get. So you're trying to get the S value as low as possible. Now obviously when you start looking at that, then if you've got one value that's like really off the line, quite clearly it's an outlier, then that's going to affect your line of best fit. It is possible, and it's probably a better thing to do is actually remove that piece of data from the data set, right? Because quite clearly, in most cases, it might be a rogue value, right? So if you want to get a true representation of most of the data, then you could say, yeah, I'm going to take that bit of data out. All right, so but also depends on the type of data you have. If let's say we looked at the heights of people in, say, year 12, right, and we had someone who was 7 foot tall, then that person who was 7 foot tall would be an outlier. They would be quite out of the normal distribution bit. In this particular case, you'd probably be reluctant to pull that data out because that is real data. It's real data. And you can be quite comfortable and confident that that data is in fact a true result. Where another case might be you've got an experiment where you've been collecting, say, temperature information, and for some reason you get a temperature result that's way off all the other values, then that may mean that your sensor is actually stuffed up. All right, so you have to be selective about when you might do that in terms of that bit of data. Now, I want to show you, obviously we've shown you the process of doing that on the calculator again, and I might just quickly go through that. So the idea when we're plotting data, going into stat plot. We've got our data there. We do our zoom line. All right, so we do zoom 9. All right, we get our data there. We do our line of best fit. Now, to work out what that line of best fit is, you go into your stat, you go into your calc, so number 4, right? And then you come down and you place that into vars, and you go into functions and place that into y1, and then we calculate that. We get our R, which is our Pearson's correlation coefficient, and this is the correlation coefficient over here, R squared, and that tells us how strong our correlation is. But we can also then say that our equation is in the form of whatever our y value is. This is the a value, okay, that goes in front of the x value. All right, so that will now give us a line which is an equation of a straight line. And then we've got our b value there. So I'd be suggesting you probably go to 4 decimal places there to get a reasonably good representation of that. Now when I graph that, it does the line of best fit for me. Right, so that's really easy process. That's what we'll be expecting you to do. Now when you start doing your investigation, right, you would need to be doing line of best fits for some of this data. So what I've got here is some data, and I might just blow this up a bit so you can see it a bit easier. Alright, so we've got some data which is looking at the rainforest. Okay, so it's giving you the time in years after a certain time. I think it was 2013, and then the millions of kilometres of rainforest that exist in, say, Brazil. Alright, so in the Amazon maybe. So if I want to do a graph, I just simply have to go highlight that information, and then I can actually do a scatter graph. Alright, so I'll do a scatter graph. Alright, I'll just make that a little bit smaller. Right, so here I've got my data. It's got the years on the bottom, and it's got the amount of hectares over there. So obviously when you're doing that, you want to be able to type in your information. So this is the area, alright, and that's in kilometres squared. I'm not getting too fussy with the formatting, but you'll get the idea. And then this here is time, and that's measured in years. Alright, so, and then you can give your graph a title. I mean, you might just go rainforest. Now, the good thing about this is it does look good, and when you're doing an investigation, you can easily put this data into your graphics calculator, or into your assignment by pasting it in. Now, if I click on the data itself and right click, then I can do a thing called adding a trend line, which essentially does what we did in our calculator. So you've got a number of different models here that we're looking at, and for most of the things that we're probably going to be doing, we're going to be trying to use a linear line. Alright, so if I choose that linear model, I can come right down to the bottom here, and it's got some options here. Okay, display the equation on the chart. Yes, I can do that, and display your R squared value. Remember, that's the correlation coefficient for that line of best fit. I can drag that over there. So that puts a line of best fit through all my data, my least square regression line. It tells me what my equation of the straight line really is, and that tells me what the correlation is for that data. So that's a really simple process. Looks really good. You can cut and paste it into a Word document, and that's great. Now, what would happen if I wanted to look at extending that line maybe for the next 50 years? Right, so what would I do there? Well, you could certainly do this as another equation. So I can copy that. If I copy that and I can paste that here. Right, so I've now got my same function. Right, I'm just going to do something with it though. I'm going to delete that line there. If I just click over here and press delete, it's going to get rid of the line. So now what I'm going to do is select my data. I'm going to do the same process again. Go add a trend line. I'm going to use the linear one. I'm going to display that. I'm going to display that. Now I can predict forward or backwards. So if I go forward, I can go to say the year, I'll go 60. So I've only done my graph for the first, maybe I'll get 100. right? So 100. As you can see what I've got here, I've got all my data that I'm actually basing this line on, and then what I'm doing is extending that line for 100 years. Now the question you've got to ask yourself is, how comfortable do I feel that this data is going to give me a good representation of what's going to happen long term? Right? So is this model going to work for the next 50 years, 100 years, 200 years? So you have to understand that if things change, like if in the Amazon we now say there's no more logging of rainforest, then this figure here will stay, at a straight line because it's not going to reduce. But if they're going at the current rate of what they're doing, this is going to tell you how many millions of kilometres of rainforest are going to be left. Get the idea? So this gives you a prediction, so long term you can look at maybe 100 years, 200, 1,000 years, what's going to happen with my model. But again, you have to be expecting, in terms of that model could change because we're basing it only on that small bit of data there. Alright, so these are the sort of things that you'll need to do with correlation when it comes to your investigation. And obviously I'll be expecting you to be talking about those things. How reliable do you think that model might be in the long term? Alright, so we're certainly going to be using that in our investigation to do with looking at data that we'll actually be looking at. Alright, so I hope this helps. It hopefully gives you the mindset what you need in terms of looking at your process here of correlation and the extrapolation of that information for long term, because that's where statistics are used all the time, okay? And it's probably the most powerful part of using statistics. Alright, good luck with that, and make sure you catch me in class if you have some problems with that.